Hello, everyone. My name is Kevin Ayers. I'm a additive manufacturing design and manufacturing engineer. Talked a little bit about myself. The presentation, though, is additive manufacturing. Where are we at and where are we going? I have a very short time to cover a lot of material, so I'll try to be as quick as I can without stumbling over my words. Perspective is everything. I've been working in the industry first for the FBI, the Federal Bureau of Investigation, for over 30 years. Then retired and worked for the Society of Manufacturing Engineers as an additive manufacturing industry manager. And then I worked for Danfoss, which is a Danish-based manufacturing company. I now am a consultant for 3D Metal Konsulting LLC. What is additive manufacturing? I encourage you to look up the ASTM and ASME standards for what that is, but basically you're building parts out of polymer or metal or composite or food or living tissue layer by layer. About 15 years ago, 3D printing, though, as a term, came into the consciousness of the world, and it's become synonymous with additive manufacturing. But to those of us who are professionals in this world, we use the word additive manufacturing primarily. There is overlap. But if you happen to Google 3D printing and then Google additive manufacturing, you'll see a completely set of different kinds of pictures involved. And you can see where the 3D printing comes over hobbyists to really cool organic statues and things like that to additive manufacturing, which are real parts. What is going on in the additive manufacturing universe? Well, same things in many cases are happening to you. We had COVID situation, Suez Canal, trade wars, etc. Extreme supply chain disruption. And in my opinion, supply chain disruption is the new normal. I think it's here to stay. And as a result of that, additive manufacturing is being forced to be in the forefront as a solution for dealing with supply chain disruptions. Another thing is every application is expanding in additive, from art and food to production and component manufacturing. Additive manufacturing is a significant part of those industries now. Another thing, as a result of the last thing, is every manufacturing paradigm is being applied to additive manufacturing. So from PPAPs to quality, repeatability, supply chain maturity, all are being worked in additive at a record pace. Another thing that's happened, because a lot of the patents expired, there's different kinds of additive manufacturing processes, and it's growing exponentially. I try to track the metal OEMs, the companies that make metal machines and sell them, and I'm at about 250 right now. And one of the biggest things that's happening is costs are going down. It used to be you didn't dare use additive manufacturing as a solution because the price was just prohibitive from doing any real work. If I can, I'll talk about additive manufacturing, 3D printing in three different major application areas, three different buckets. Rapid prototyping, which includes models, rapid tooling, and end component manufacturing. Models is something we kind of haven't been paying attention to lately, but in the additive world, things have really got interesting. We have some machines like Mamaki can print in 20 million different colors. So that pizza you're seeing was actually a polymer you're seeing. And you can do translucent, you can do solid colors, you can vary the tint and hue. It's amazing what it can do. Models save time and money. You walk into a conference room, you hand a model around, it really, really improves the communication and the speed of communication. And communication itself is a key in product development. So you can do multiple designs real quick, show them off, get new ideas, and really speed up product development and eliminate errors while you're doing that. Tooling in additive manufacturing is widely being used now. At my former company, Danfoss, we probably did over 300,000 pieces of tooling, especially multiple copies of tooling. It's very great weapon in doing tooling, and I'll discuss why that is. The reasons for making your tooling out of additive manufacturing. All the tool files are digital, which is important in manufacturing 4.0, industry 4.0. They're easily stored and easily modified parametrically. You have the ability to do on-demand tooling. So your short parts or major part breaks, you can literally push a button, which is really not much cost from labor from that point, and avoid line closures. At Danfoss too, we're able to, you can have, in this global world we live in, we can have different areas of the world are doing the same production line. And it's easy to put a new line in another place worldwide. The files are digital, we just print them, and you can go from 3 months doing a product line down to 3 weeks. Ergonomics is really coming into play now. Your tooling can be modified. So you could have a 6'4", 200-pound man on one shift and a 5.5 foot 7-inch a lady in the other hand, and the tooling needs to be different. The people become more efficient. You can do more assemblies per hour faster, and the operator is less sore when you're done. There's no geometric limitations, and you can use exotic materials economically, materials like titanium and metal, and long fiber composites in tooling. Also, what's come into the I don't want to say fad, it's not really a fad at all, but it's being sustainable. Additive manufacturing is very green technologies. You use much less waste than other manufacturing processes. One thing we found out at Danfoss, too, the operations staff is much more involved in the design, making changes and wanting to make changes because they know that we can make those changes quickly and cheaply. Here's an example of a piece of tooling I did in bullets. These are disposable tooling. They're used generally for 20 different assemblies, and then they're discarded, sometimes a lot more. We did this at, what the bullet does is it fits over a spline shaft on a motor or a pump, and you slide a lip seal over that. If you don't have that guard, the lip seal can nick and cause a leak, which is bad news. Sometimes the nick won't cause a quality problem right away, but eventually it will. The first impetus was to do this to reduce the cost of the bullet. We went from an average of $125 machine down to $6 3D printed. We improved the quality by having a more repeatable process, and this reduced the amount of shaft seal leaks we had worldwide. We had to develop a cross-functional team with this, and this got a lot of people involved in additive, as you can imagine. We had to study how the bullets were designed, and many of them had been designed 40 years ago. So we had to make a lot of changes. We had to look at different additive technologies. We used a lot of different people to test this out, and the strengths of additive manufacturing industry 4.0 to give a final product. So some of these might be familiar with the Gardner hype cycle of emerging technologies. And there's different opinions of this, but this is pretty good. The two items in red are consumer 3D printing, which is really the printing of real components, and enterprise 3D printing are for people who are designing hairbreadths or cell phone calculators for personal use. And we're starting to get to maturity as we need in the industry. And again, things like COVID has really sped things up. End component manufacturing. This is the highest ROI you can see. We first started doing end component manufacturing additive, especially metal, to get enhanced performance by making geometries you couldn't make any other way. Generative was a big part of that, making these generative design. And really the designs that come out of the generative design software primarily can only be made out of additive. So it's a mutual symbiotic relationship that's forming this way. And we went after small production runs too. At Danfoss, we were able to do small production runs to keep lines going. And even though the cost normally would have been prohibitive, we were able to keep the lines up. It actually saved us money. And there's also some penalties we were incurring per day from some of our customers because we wouldn't do that. But one thing I want to talk about that's really interesting is things have really changed in this world. 3D sand printing of molds has sped up. The printers are becoming cheaper. The price of sand is cheaper. Where you put them in a foundry is at the end of the foundry instead of the beginning. And so, and that's where the bottlenecks are in the beginning, usually in a foundry. And you're able to price competitively print castings. And the quality of the castings are much better. So you have more dense castings and you have less porosity in the castings. So that you actually have a much higher quality. My friends at Chrysler and Ford are going completely to sand printing for the future in their castings. Binder jet metal is taking off and things are becoming better on dimensional control, but you can print parts more cheaply, especially parts that are basically 2.5 dimensions. But you can still print internal channels and things like that. And binder jet metal uses powdered metal or MIM directly in their machine. So you get a lot more alloys than are used in conventional additive manufacturing metal. And we're seeing a lot more fast polymer printers that are rivaling the speed and cost of injection molding with no tooling. That's all I have for you today. I'd like to answer any questions you have. I'm available for that, either in the next few minutes or later on. I'll have my email contact put out. Thank you.